look at laws of exponents, and we're going to change the basis for it. And the law we're going to look for exponent is the power law. And the power law is the idea if you have some base to the power of a, and then that is to the power of b, it can be simplified by just writing that same base a times b. So just multiplying those two exponents, okay? So that rule comes in handy here because they're asking us to write 4 to the power of 3 as a base of 2. I could evaluate this, and this becomes a relatively large number, maybe like 64, and then I got to figure out what 2 is to 64. That is one way to do it. Another way we could do it is kind of using substitution. Let's actually focus on the base in the question, the number 4, and the base they want, the base of 2. I'm going to think off the top of my head, 2 to the power of what gives me the base of 4. Do we have a number? Do you know what 2 to the power of what could be that?
2.
2, that's right. 2 to the power of 2 is equal to 4. So what that means is I'm going to replace 4 with 2 to the power of 2. And this 3 is going to be like the power outside of that base. So now when we go to rewrite it, we write 2 to the power of 2. And then to the power of 3. Okay? And then we simplify. We would just multiply those two exponents. And what is 2 times 3?
6.
Yeah, so 2 to the power of 6. And just to check it out, let's test our 2. 4 to the power of 3 gives us, like we said, 64. And 2 to the power of 6 gives us 64 again. Perfect. Worked out great. So let's try a more difficult question here. There we go. In this question, I have 1/8 to the power of 5. We're going to use that power law again, or that power rule. Same idea. I'm going to focus on this and the base they want it in. So I have to think 1/2 to the power of what would be equal to 1 over 8. Now, fractions can look intimidating, but remember that 1, so first of all, this power is technically the entire fraction. It's 5 like that. So one way you would write is over 8, 1 over 8, 1 over 8, etc. 5 times over. The good thing is about multiplying fractions is you just do the tops by the tops, and 1 times 1 is always 1. So we really don't got to focus on the numerator here. I almost forgot what that was called. We don't have to focus on the numerator because 1 to the power of anything, infinity, is going to be the number 1. Okay? What we really want to focus on is this 2, and how does it become an 8? Okay? So how can we get 2 to be 8? 2 to the power of what gives us our value of 8?
4.
Okay, let's try that. 2 by 2 by 2 by 2. This would give me 4 times 2 again gives me 8 times 2 again gives me 16. So we went 1 over. What should we be looking at? We said 4, and 4 was 1 too high. So our power should be, in this case, it should be the number 3. Okay? And you can test it. Again, it's not expected that you memorize these things. But 2 to the power of 4 gave us 16, a little high. 2 to the power of 3, 8. Perfect. So what we're going to do now is we're going to replace 1/8 with, and I'll rewrite it again here, 1 over 2 to the power of 3. Okay, think of it like this, though they don't write it like that, is equal to 1 over 8. Well, let's write this. We're going to replace the 1/8 with that idea. So we end up at 1 over 2 to the power of 3. And then what was the power on the 1/8? Was it 5? So we write that as a power of a power. Okay? We keep our base. We still have a half. And we have to multiply the two exponents. What is 3 times 5 going to be?
15.
15. So according to this, 1/8 to the power of 5 is the same as 1/2 to the power of 15. All right, here's the test. My calculator doesn't do fractions very well. I don't think, at least. To the power of 5. Okay. Very odd looking number. What this means, we take this decimal and move it 5 to the left. It's a super small decimal. Be easier if they wrote it as in a fraction. Unfortunately, mine doesn't do that. But I should get the same answer when I put the other one in. So brackets 1 divided by 2 and bracket to the power of 15. And hey, look at that. They're identical. Which means essentially it's the same value. It's a really, really small number, whatever it is. Okay?